Hello, grade 11s. In today's lesson, we're going to be looking at empirical formula, and we have some of our exam type questions just to explore the topic. So, put on your seatbelt and let's go. So, okay, without any further ado, let's look at question 6. We have 6.1. It says methyl propanoate is an organic compound with the following percentage composition. So, we are given 54.55% carbon, 9.09% hydrogen, 36.36% oxygen. So the first thing that you want to do here is just to change this percentage from each element here to grams, right? So we're just going to take these percentages as our mass. So here we have 54.55 grams, then here 9.09 grams, and then 36.36 grams. So that's what you do. Simply replace the percentage with grams. Then the molar mass of the compound is 88 grams per mole, right? So we are given that methyl propanoate has a molar mass of 88 grams per mole, right? And then 6.1.1 says define the term empirical formula for 2 marks. So this is how you define it. You say empirical formula is the simplest whole number ratio of all the elements in a compound. Note how I'm saying whole number ratio. So this will play a big role in terms of our calculations. We have to find a whole number, right? So no decimals. Then 6.1.2 says determine by calculation the empirical formula, and that for 6 marks. So remember, as I always tell you, 6 marks does not indicate the difficulty of the question, but rather that we have to use maybe multiple formulas, or maybe the process is a bit long, but then it has nothing to do with the question being difficult. So you just need to take a chill pill. Then, okay, 6.1.2, the first thing that we want to do, so for our step 1 in calculating empirical formula, is to calculate the number of moles. So we want to calculate the number of moles of each element. So calculate number of moles of each element. Then, okay, so we have the first element is carbon. So we go N is equals to M over big M. And then the second one, we have hydrogen. Again, N is equals to the mass over the molar mass. And then lastly, we have oxygen. Number of moles is equals to mass over the molar mass. So now we're just going to do that for all these elements and then start calculating. Remember, the mass is 54.555 for carbon, and then what is the molar mass of carbon is 12. So note that the molar mass will be the molar mass of each individual element, right? Then here we have the mass is 9.09, and then the molar mass of hydrogen is 1, and then for oxygen we have the mass is 36.36 and the molar mass is 16, right? Then at this point you just want to calculate this and round off to at least 4 decimal places, because right now we are still calculating the number of moles. So it's 4.5458 mole. So I don't want to lose any values. So that's why I'm rounding off to at least 4 decimal places. But then you can also round off to 3 decimal places. Just that do not round off to 2 decimal places as yet, as you might lose some values. Then okay, so now we are done with step number 1. It's calculating the number of moles of each element. Then let's move to step number 2. So in step number 2, we want to now take step number 2 is to divide throughout by the smallest number of moles. So by the smallest number of moles. So now we want to look at the smallest number of moles here and divide throughout by the smallest number of moles. So looking at our values here, we can all agree that the smallest number of moles is this one, 2.2725. So we're just gonna divide every value there by the smallest number of moles. So we have for carbon, it's 4.5458 divided by 2.2725, and then we have for hydrogen, it's 9.09, divide again by 2.2725, and then this one we have oxygen is 2.2725, then obviously we'll divide by the same number, 2725. So what will be our ratio now? When punching this in your calculator, you will find that the ratio here is 2. So we have 2.00, but then we are only focused on the whole number, so we do not mind the decimals that come after. So we have this 2, and then the hydrogen here is 4 exactly, and then the oxygen is 1. So now step number 3 is to obviously write your empirical formula. Write your empirical formula. So now that you have this, you have carbon 2, hydrogen 4, oxygen 1. So your empirical formula will be C2H4 and O. Ta-da! Okay, so now cool. Now that we have the empirical formula, 6.1.3 here is saying determine the molecular formula, right? And that for only 2 marks. So remember, when we were still reading, we were given that the molar mass of the compound is 88 grams per mole. So how do we now determine the molecular formula? Simple. So the first thing that you want to do when they ask you for the molecular formula is to first calculate. So let's write step 1 is to first calculate the molar mass of the empirical formula. So calculate the molar mass of the empirical formula. So remember, this does not take as long as this when you are solving. It's just that I'm going step by step. So remember, the empirical formula was C2H4 and then O. So now we must calculate the molar mass for this one. We are saying how many carbons do we have here? It's 2. And then the molar mass of carbon is 12. Then plus how many hydrogens do we have? 4. But the molar mass of hydrogen is 1. And then how many oxygens do we have? Only 1. So we're just going to say 16, because the molar mass of oxygen is 16. Then you just want to punch all this in your calculator. So you'll have 44 grams per mole. And then now step number 2 is to divide the molar mass. So divide the given molar mass by the molar mass of the empirical formula, by the molar mass of the empirical formula. So make sure you pause the video and take note of all this. And then now remember, the given molar mass was 88, so we're going to have 88 over 44, and that will give us 2, right? So this 2 indicates the factor ratio. So the factor ratio is what we now going to multiply with on the empirical formula, so that we have the molecular formula. Remember, the molecular formula represents the chemical formula of a particular compound. So this is only the simplified ratio form, but then now we are looking for the chemical formula as it is. So hence we calculate the molecular formula. So step number 3 is to obviously write your molecular formula. So write your molecular formula. So obviously the molecular formula, how do we write it? We take this 2 and start to multiply on the empirical formula. So we have this 2 multiplied by 2. So now how many carbons will we have? 4. And then it's this 2 multiplied by this 4. How many hydrogen atoms will we have? 8. And then it's this 2 multiplied by the 1 on oxygen. So how many oxygens will we have? 2. And tada, that's how you have it. 2 marks. Okay, let's move to the second activity. We have question 6. It says aspartame is an artificial sweetener with the following chemical composition. It has 57.14% carbon, 6.16% hydrogen, and 9.52% nitrogen, then 27.18% oxygen. Now 6.1, we can see that it's asking us for the very same definition, empirical formula. So what is it again? Empirical formula is the simplest whole number ratio of all the elements in a compound. Remember, if you want to know your definition, keep on writing it as many times as it appears. That's how you make sure that you have a grasp on that definition. Remember that 2 marks is very important. Then 6.2 says determine the empirical formula of aspartame, and therefore 5 marks. Right, so here we are given 4 elements. We have the carbon, hydrogen, nitrogen, and oxygen. Then again, we want to go through with our steps. So remember, step 1 was to calculate a number of moles of each element. Right, so we're still gonna go through with our steps so that you know very well that they work. Then okay, we have the first element is carbon, so it's n small m over big M, and then we will have 57.14 and then over 12, and then followed by our hydrogen, n is equals to small m over big M. Then we are given 6.16, and then our molar mass is 1, and then followed by nitrogen. So its number of moles is equals to mass over the molar mass. We have 9.52, and then for nitrogen in the periodic table it's 14. And then lastly we have oxygen. Then the mass was 27.18. over the molar mass is 16. So let's have our answers here. We have 4.7617 mole, and then this one is 6.16 mole, and then this one is 0.68 mole, and then oxygen is 1.6988 mole if we round it off to 4 decimal places. Then we know our step 2 is to divide by the smallest number of moles. So which one is the smallest number of moles here? We can all agree that it is 0.68. So for carbon we will have 4.7617 over 0.68. hydrogen 6.16 over 0.68, and then nitrogen 0.68 over 0.68. Then oxygen 1.6988 over 0.68. So okay, now let's find our ratios. For this one we find that it is 7, and then here we find that it is 9, and then for this one it is obviously 1, and then here we have 2.5. Now this is where the trouble starts. What if you have 2.5? So this one was 2.49 something, which can be rounded off to just 2.5. So if you have a value like this, 2.5, so if you have a decimal place that is 0.5, then you have to know that you have to multiply everything here by 2. Right. So remember, when going back to our definition, remember I said this will be very important during our calculation. Let's read this definition. It says empirical formula is the simplest whole number, right? Whole number ratio. So why is it important? Why am I highlighting the word whole number? Because you need to note that we cannot write our empirical formula in a form of a decimal, right? So we need this one to change to be a whole number. How can we change 2.5 to be a whole number? We can simply just multiply it by 2. But then remember, the rule of maths doesn't allow us to only multiply this by 2. Whatever that we do to this value, we must also do to all these other values, so that we maintain the same ratio throughout. So if we multiply by 2, we also need to multiply the other ones by 2. See? So now that means we'll have 7 multiplied by 2, that's 14. And then 9 multiplied by 2, 18. Then 1 multiplied by 2 is 2. 2.5 multiplied by 2 is 5. Then writing our empirical formula now, we will have C 14, H 18, N 2, and O 5. That becomes your empirical formula. So that's how you go through it. Make sure that you pause the video, guys, and try to understand all the steps that I've went through. Okay, 6.3 says if the empirical formula is the same as the molecular formula. So they're saying if the empirical formula is the same as the molecular formula of aspartame, calculate the molar mass of aspartame. So that one is just for 1 mark. So that means we have the empirical formula is the same as the molecular formula. That means they will have the same molar mass. The empirical formula will have the same molar mass as the molecular formula. So that means we can use the empirical formula to just calculate the molar mass. So remember, it was C 14, H 18, and then we have N 2 and O 5. So to calculate the molar mass here, we'll just say 14. We'll just say 14 times 12 plus 18 times 1 plus how many nitrogens do we have? 2. And then times 14. And then how many oxygens do we have? 5. And then times 16. So we're just gonna punch all that in our calculator, and then it will give us 294 grams per mole. That's how you have it. Awesome. Okay, so let's look at activity 3. We have this question 7. It says the chemical composition of a particular compound is 11.79% carbon, 69.57% chlorine, and 18.64% fluorine. It says the molar mass of the compound is 204 grams per mole, determined by calculation the molecular formula of the compound. Okay, so now let's start off with our step number 1 to calculate the number of moles. So the first compound that we have is carbon. So N small m over big M. So we'll have 11.79 over the molar mass of 12. And then followed by chlorine, N small m over big M. And then what do we have? It's 69.57 over the molar mass of 35.5 from the periodic table. Then we have fluorine is N is equals to small m over big M. And then we have 18.64 over 19, the molar mass from the periodic table. Then let's calculate here. So rounding off to at least 4 decimal places, we have 0.9825 and then mole. Then this one, when we punch it in our calculator, we have 1.9597 mole. And then what about fluorine? We have 0.9811 mole, right? Then we know step number 2 is to divide by the smallest number of moles. So we can all agree that the smallest number of moles is the one for fluorine. So we'll have 0.9825 divided by 0.9811. And then here we have 1.9597 over 0.9811, and then here 0.9811 over 0.9811. So for carbon, the ratio is 1, and then here the ratio, so the value that we have here is 1.99, which can be rounded off to the whole number 2, right? So remember, we must write whole numbers. So 1.99 can be rounded off to 2. And then here, this is just 1, right? Okay, so the ratios we have 1, 2, 1, meaning our empirical formula. So writing our empirical formula, it will be Cl2F. But remember, the question here is asking for the molecular formula of the compound, and we are given the molar mass to be 204 grams per mole. So what must we do now? Remember, when we want to calculate the molecular formula, the first step is to first calculate the molar mass of the empirical formula. So we have Cl2F. So we want the molar mass of the empirical formula. We have 12 plus how many chlorine atoms? 2. And then chlorine, the molar mass is 35.5, and then fluorine is 19. So if you punch all this in your calculator, you have 102 grams per mole. And now we are looking for the ratio factor, which is, we'll take the molar mass, the given molar mass, 204 grams per mole, and then we're gonna divide it by 102 grams per mole. So at this point, 204 divided by 102, we will have the ratio factor of 2. And then now what do we do with this ratio factor? We multiply it on the empirical formula so that we have the molecular formula. So the molecular formula will now be carbon. How many carbons do we have? Only 1. But now multiply by 2, we'll have 2 carbon atoms. And then how many chlorine atoms do we have? 2. Multiply by this 2, we'll have 4 chlorine atoms. And then what about fluorine? We only have 1. Multiply by this 2, we'll have 2 fluorine atoms. And that's how you have your molecular formula. Danko!